for plastic, for paper, for so on. We call it waste separation. And that's it. I'm not going to go through all the items. I just focus on the main items. As you see, it starts from here. It means that if you have waste, okay. Now we separate them and recycle them. And here, this is us who make waste. Then there is waste collection, and then it goes to the plant for recycling. And before that, it should be separated. And when it is recycled, some part of it could be used again, and some part could be used for energy generation. All these needs management. It needs a management. Even if you have all the elements, without any management, it does not work. Therefore, management of waste is very important. Also, in a smart city, you have a smart transportation system, such as they are battery operated, most of the cars, not petrol. And sometimes they are solar powered, which means you use the energy of the sun. Also, you have cycle tracks. It means that most of people use bicycles. Here in Indonesia, many people, as I noticed, they use motorcycles, which is good. Next step would be use battery motorcycle. If you come to Iran, unfortunately, the use of motorcycle is not that much. Everybody uses car, and it's not good at all. If you change it to motorcycle and change it to bicycle, that would be the best solution. Well, let's go to the car. As you can see here, it's the solar energy. This is a bus, and its energy is provided by solar energy. Or as you can see here, you have electronic cars, and you have routes for the bicycle. And here, if people just walk, is the best way. If it is not possible, they should use bicycle, then use public transportation, and so on. In some countries, this triangular is the other side. This is the worst situation. This is the best situation that in some of European countries and even in Asia, in some countries, you see such a triangle, which is very good. The other is water management. Water management is important in two types of countries. First, countries with lots of rain, like Indonesia, and people without much rain, such as Iran. Okay? Here, rainwater is very important, even if you have lots of water or little water. The water comes from the sky, and we should use it. Why not to keep it? The other thing is proper waste water treatment. It means if we go to bathroom, this water could be recycled again and be used. In many countries, in many cities, you have two different of water piping. One is for drinking water, and the other is for ordinary use of water. I don't know, in Surabaya, do you have one system or two systems? Two systems, which is very good. But if you come to Isfahan, in my city in Iran, we have one system. But if you have two systems, it's a better solution. Well, as you can see here, if you know, this may be better than me. If there is raining here, you can design your building in such a way that it gathers water of rain. It goes down in a tank, and it could be purified as drinking water, because rain is very good. You can drink it if you purify it quickly, and also you can use it as waste water. And this is the system. And if you have so many of these buildings in a country with rain, like here in Indonesia, I think that would be one of the best solutions to keep water, and that's it. Then we have air quality management. I don't know, do you have air pollution in Surabaya? Despite the fact that you have lots of rain. But imagine if you come to my country, which there is no rain and lots of pollution. In Isfahan, I remember when I was at your age, about 20, 22 years, always the sky was blue. There was no pollution. We didn't know what is air pollution. Believe me. The first time I saw air pollution, it was about 30 years ago. I was on the top of a building in the square in Isfahan, and I couldn't see the other side of the square. It was, and I didn't know what, and they told me it is air pollution. Unfortunately, today, if you come to my city, to Isfahan, most of the days it's a polluted day. You should wait for 1 month to 3 months, maybe, that you have a air quality, good air quality. And imagine we do not have that rain. We just wait for winds to come, and it's just for 1 or 2 days. Therefore, you need increase green spaces. You need to have green walls. You need to have green roofs. And you should have air quality monitoring. Okay, I'm sure you have such a system, but still maybe we need to increase them. Here, as you see, this is a green wall. These are green walls or green roofs. Do you have such a green roof architecture in Malaysia? In Germany, they have. In every building at the roof, it's green. They make some grasses or some trees in order to, I'm not sure whether it is in Malaysia. Maybe you don't need, because you have lots of trees and green spaces. Is it right? Yeah, you have it. That's great, that's great. Therefore, one good solution is to have such a green buildings with green roofs and so on. And then security or safety for the people. You add CCTV cameras, you have neighborhood watch program, and you have volunteer work that coordinates with law enforcement people. Well, let's go to a smart city and see what are the materials in a smart city, because construction materials are also very important. I give you some examples. You could have roads whose pavement is made of waste plastic and waste materials. It means that you don't need to use asphalt. You don't need to use oil in order to make your pavement. And if you use from waste material, that would be a very good solution to the problem. Also here, it is permeable concrete. It means that when there is raining here on the ground, the water goes down in a specific location, such as canal, diverting canal, and then it conveys water in a tank to keep it. Therefore, in some countries with lots of rain, one best way is to make permeable concrete or permeable pavement or such pavements in order to absorb and keep water and use it later on. Also, you could have a smart street lighting. As you see, if the lights in the streets are powered by solar energy, that would be very good, and it reduces the consumption of fuel energy. Therefore, if I want to conclude or collect what I said, in a smart city, everything is smart. Each single building is smart, as I explained, and I will explain later. The streets are smart. The parkings are smart. They are interconnected by wireless system, and somebody in the municipality building or buildings, they monitor everything in order to make sure that everything is working. And imagine if you have such a smart cities, you can save lots of energy. And when you save energy, you use less energy. There is less pollution, less hectic situations for the people, and people can live more easily and without any stress. These are very quick and simple definitions for a smart city. Would you like to add something?
Okay. Materi pertama yang dipaparkan oleh Profesor Hijazi adalah tentang smart cities, di mana konsep energi consumption di sini yang pertama ditekankan adalah tentang karakteristik dari smart cities. Yang pertama adalah bagaimana pemanfaatan energi, pemanfaatan sampah dengan cara mengurangi single waste, sampah single waste. Kemudian yang ketiga adalah penggunaan transportasi. Kalau kita di sini biasa menggunakan motorcycle, di smart cities penggunaannya lebih ditekankan kepada penggunaan bicycle atau sepeda. Kemudian tentang water management, bagaimana mereka menanggulangi kekurangan. Kalau di Iran tuh kasusnya adalah kekurangan air. Kalau di kita mungkin air ada, tetapi bagaimana cara supaya kita bisa mereuse air, misalnya air hujan, dengan cara tadi disampaikan ada harvesting rain. Kemudian yang kelima ada tentang udara. Karakteristik adalah kualitas udara. Kemudian yang terakhir adalah keamanan dan keamanan dari sisi keamanannya. Kemudian material yang sudah bisa digunakan untuk pengembangan smart city adalah dengan pemanfaatan sampah plastik pada penggunaan jalan untuk pembuatan jalan. Kemudian ada beton yang bisa menyerap air sehingga bisa mengurangi banjir. Kemudian ada penggunaan lampu jalan otomatis. Itu adalah material yang bisa digunakan untuk smart cities. Sementara di terakhir, smart cities itu intinya adalah connecting antara parkir, bus stop, lampu, serta penanggulangan sampah yang semuanya sudah terkoneksi. Itu pengertian smart cities dari Profesor Hijazi. Yes, please.
Thank you. Now we go to the next section, which is smart building. I explained about smart city, and also I explained quickly about smart building. Any of the students would like to tell me what are the features of a smart building? I will help you. Who is interested to tell what is a smart building?
Ada yang mau menjawab bagaimana karakteristik smart building menurut teman-teman di sini? Nggak apa-apa kalau nggak yakin, nggak apa-apa dijawab aja.
I help
Biar
you.
Ada...
Don't worry. Who would like to contribute? It doesn't matter if it is correct or not. Please.
Yes,
yeah.
Please. Oh.
Yeah, my name is Bayu, and I will explain about the smart building in it. I think the smart building is a building that have advanced technology in that building and have any characteristic in smart cities, such as zero waste and many more. Thank you.
Okay, good. Thank you very much. That was right. If we have a look at this figure, this is the smart city, the largest portion. Then you have one of the main objectives is to reduce energy. And to do so, you must have a smart grid, a smart network in order to connect everything and or connect elements. One of the elements is the house or the building. A building could be a house or anything. And therefore you have elements which are smart buildings, okay? Here, I read over this text, smart buildings are intelligent buildings. Smart buildings include intelligent building automation systems. It means that inside the building, everything is automated and they are connected to each other and you can manage it, you can support it. In a smart building, you have smart devices. I will explain later. And there you have productive users. It means that you have smart devices and people inside the building know how to use that. It means that if I have a mobile phone, I know how to use it. If I have the mobile phone, but I don't use it, it's useless. I should throw it away, okay? Therefore, people should be trained how to use a smart building. Well, if you have a look at this diagram, you have individual buildings. It could be a small house, it could be a large building, it could be a factory, and so on. Inside each of them, you have a smart system, and these smart systems are connected to each other by a smart network, which means if, say, there is the main management department, say, for example, in the municipality, and if something goes wrong here, this management office is responsible to come and resolve the problem. As, for example, today, if you have ordinary electricity and it runs off, there is a specific office in the municipality who should come and resolve the problem. Here, you have a smart building. They are all connected by Wi-Fi and so on. And if something goes wrong, somebody would come and resolve the problem. There are some elements like here. They are wind power park. They produce energy. They are solar panels. They introduce energy and they work and they should work together. It means the whole city or elements are interconnected through a smart grid or a smart network. Now, what are the features? What are the characteristics of a smart building? First, a smart building has four main elements. The first element is the structure. The second is the systems inside. The third is the services that this system produce for us. And fourth is management. You don't see management here, but the fourth is management of the previous three elements. Therefore, in a smart building, you should optimize the operation of these four elements. It means that if we have mobile phones here, we should optimize our usage of this mobile phone. Otherwise, it is not very functional. I go, well, we have green buildings and we have smart buildings. There's a difference between. As you can see here, when we go for a smart, for a green building, we have eco-friendly materials in a green building. We have water efficiency, we have transportation efficiency. But when we come to a smart building, we have advanced system to operate, and we have advanced structural system. Therefore, the advancement or the advanced system which is used in smart buildings is something extra that you don't use in a green building. A green building could be a very old building, a historical building, but still it is not smart. If you add some devices inside a green building, then the building would become a smart building. Well, if you have a look here in a smart building, you see what are some outcomes, what are some results. For example, in this building, there has been a 30% saving in water usage. It means that you have reduced the consumption of water by 30%. Or here, you have a reduction of 40% of energy, which is so high, the reduction of energy. And also here, for every building, you need maintenance. And if you use a smart system in a building, you would decrease the maintenance cost by 20 or 30%, as it is written here. It means that at the beginning, maybe you need to pay money for a smart building, but in long term, you will have saving for your money. And it is not the matter of money. More important is the nature, is the atmosphere, is the environment. Everything would benefit from this smart building. Here is a question: how will the smart grid or smart network impact buildings? Well, if you have smart devices in a building, they should work together. They do not work individually, okay? Therefore, you need an expert to design the connection or the grid for the smart building. And it is a field. You should go and study for it, how to use it, how to connect it. If a civil engineer or a construction management engineer like you can do it. We can do it. We need to get some courses to do that. As you can see here, again, you have lighting load controls. For example, if lots of light is on and lots of energy is used here, automatically the main control system will check it if such huge amount of light is necessary in this building, in this room or not. If it is not, it will automatically download.
يعني المؤتمر هون وهيدي المقدمة هاي أكيد تركيب من حكي يومين وهو موجود هون حجاب.
Okay. Oh, let me go through. I just pass over this. Well, somebody would like to come in. Okay. Here is the system for controlling a space, a conference room like here. As you can see, there's a thermostat here in order to adjust the temperature, and also there are some sensors, and there are some noise detectors, some temperature detectors, humidity detectors, even CO2 detectors. It means that everything is monitoring at the time, and if something goes wrong, they automatically change it in its optimal function. And as you see here, there is a smart AC control. It means the atmosphere, the air conditioning of the system is automatically controlled. It is not just with a thermostat to change the temperature, but everything, CO2 and everything would be controlled and changed if it is necessary. Even there is a center in the building which controls the lighting. It automatically detects if somebody is not here, the lights would be turned off. And when people come in, it would be turned on. Maybe you have such experience, but everything here is controlled. And there is a central remote control system or control room. Sometimes somebody is sitting there checking everything. Sometimes the computer itself will check everything, and if any adjustment is needed, it would do it. Let me go to next section. If you have any comments, please. And then
I need to just translate it.
No comment.
Translate before you.
Yes.
Oke. Materi berikutnya adalah tentang smart building. Smart building menjadi bagian dari smart cities, di mana smart building ini adalah bangunan dengan otomasi sistem, dengan perangkat yang cerdas, tetapi poin pentingnya adalah bagaimana bangunan smart building ini juga harus dilengkapi dengan productive users atau pengguna yang bisa menggunakan perangkat tersebut. Nah, smart building ini masing-masing smart building ini dikoneksikan antara building dengan fasilitasnya sehingga ada manajemen yang bisa mengontrolnya. Salah satunya adalah misalnya dengan ada sebuah manajemen device yang bisa mengontrol pengaturan energi di dalam sebuah building, dalam building maupun koneksi antar building. Kemudian beliau tadi juga memaparkan tentang perbedaan antara green building dengan smart building. Pada prinsipnya ada hal yang sama, tetapi pada green building jika ditambahkan dengan device baru yang merangkap ke smart building, maka green building tersebut bisa masuk ke dalam smart building. Yes.
Thank you. Now we go to next section, next part. Well, I'm adjusting my time. It's a smart time in order not to talk too much. That's the reason sometimes I look at my mobile phone. Well, let's go to next section, which is zero energy building. It's a zero energy building we call ZEP. At the moment, suppose we have a smart building, but it doesn't mean that the energy consumption in this building is zero. Therefore, first step is to have a smart building, and next step or final step would be how to reduce the energy consumption by zero. What are the features or characteristics of a zero energy building? ZEP. A ZEP is a building with zero net energy consumption. When we say zero net energy consumption, it means during 1 year. It means, number two, the total energy used annually per year is roughly equal to the energy generated through renewable resources or sources. Well, the building consumes energy. It doesn't matter, it should do that. And we have reduced this consumption. But how the energy is generated for the building? If the energy is generated by renewable energies, not by fuel energy, therefore the consumption and generation is somehow equal. The total summation would be zero. Therefore, if a building itself be able to produce its own energy, we call it a zero energy building. Number three, ZEBs contribute less greenhouse gas is one of the main objectives in order to not pollute the nature, to produce less greenhouse gas. ZEBs contribute less greenhouse gas to the atmosphere than non-ZEBs. Ordinary buildings that we have, we damage the nature, but if it is ZEB, it doesn't damage, or the damage would be minimum. Why ZEB? Why using zero energy buildings? First, to overcome energy crisis. At the moment, in some parts of the world, it's energy crisis. Maybe they cannot produce, or they cannot buy, or something like that. Number two, to reduce energy consumption. And number three, to protect environment. It is the main goal, to protect the environment for future generations. We are responsible for next generations. As our parents, our old generations were responsible for us, now we should get the environment and hand it over to next generation in a better situation. This is the responsibility that we have. How to get a zero energy building? First, we should have appropriate site selection for the building and appropriate orientation of the building. I will explain later. Number two, reduce heating, cooling, and lighting loads of the building. Through what? Through climate responsive design. It means that we should have a climate responsive design of the instrument or of the devices, which we call it a passive design. Now we should have a passive design of the building. I will explain in next slide what is a passive design. And four, to use renewable or high efficiency energy sources. Okay, it means that we shouldn't use fuels or electricity which is produced in the plants. We should use renewable ones. I will explain this in next slides. Passive design is very important. Imagine we are 1,000 years ago. We are in 2,000 years ago. There is no energy, no electricity. There is no petrol, no fuel, nothing. What you have for energy is wind, sun, maybe wood you can burn, and so on. When you have a passive design building, in this building, no auxiliary equipment are required to make the system function. It means here, as you can see here, you have a cooling system here. You have lighting system here, and so on. It means this building is not a passive, it is not designed based on passive concepts. It doesn't matter. Everywhere in the world is the same. But we should change our concept. How? In this way. If you choose a good orientation for the building, your building could use sunshine, could use wind, and so on. If you have designed the arrangement of windows. I will explain later. You could get enough light if you need, and so on. Even if you use suitable shading, if there is too much sunshine, you can prevent it from coming down and make it warm inside. The envelope, the walls and the roof of the building also should be designed in a passive way. I will explain later. You should be able to use daylighting. And also, you should have a high thermal mass, I will explain later, in your building. And also, every energy consumption should be adaptable. It should be adapted to renewable energy. These are the main features that a passive design should have. I will explain in next slide. Here, your building should be able to catch the sun, or sometimes to be prevented from the sun. Your construction should be airtight. It means no hot or cool air come or go outside, inside or outside. You should have a good insulation for thermal. You should have high efficiency windows and doors. I will explain how. And you should have heat recovery and ventilation, which is natural. Here in this building, we don't have a natural ventilation unless we open two of the doors or windows, one this side, then we have a ventilation, natural ventilation. We should have solar water heating, which is very important. In order to use electricity to make water hot or warm, it's better to use the solar energy. And also you should have efficient air conditioning that I will explain to you later. Well, if you were 200 years ago, 2,000 years ago, I could give you some explanation. Maybe if we have time, I will show you some examples in different parts of the world that they made passive buildings. But let's go to future, or come to the present day, because in present day we are using modern system, modern materials, modern buildings. There are so many examples in the world. I just take you into United States. It is a National Renewable Energy Laboratory, which belongs to the government, and they are working on energy usage of the buildings. Well, if there is authority in your country and it is responsible for energy, this organization itself is supposed to have an energy efficient building. For this reason, they design their own buildings in the organization as smart buildings. As you can see here, on the roof of all buildings, there are some solar panels. It means that we are using the solar energy. And also, if you see, we are in a vast area. It's near the mountains here. It means that here is lots of wind, and they can use wind as energy. I will show you later. Also, as you can see here, is daylighting. As you can see, the building is very long, and two sides of each building is open to the air. It means that in every single point of this building, it is possible to use daylighting. Therefore, they don't need to use artificial lighting like what we use here in this building. For the fenestration or for the windows, as you can see here, in these buildings, they have used smart windows. As you can see here, the windows automatically can be closed or open, depending on the temperature of inside and outside, and depending on the wind speed. Also, for the daylight or for the sunlight, when they need sunlight, as you can see, these blades would be opened. And when the sunlight is too much and they don't want to have sunlight, these blades would be closed. It means that automatically they can use the light of the daylight or not. Shall I continue? Good. Now, if you have a look inside, it's very bright inside. And as you can see, the light is taken from outside. And here you don't see any artificial lamps, unless during the night. It means that here the energy consumption for lighting is minimized. Also, here, as you see, the color of the walls are light, as here. As here, they have used white-colored surfaces in order to reflect the light, which is very good. Here, as you can see, they are going to, or they have increased thermal mass. It means, when we say thermal mass, it means this. If you have sunshine here and sun comes to here, it's the wall. It is a very thick wall sometimes, or it has a wall material with high thermal mass. It means that when it's very warm here in the summer, say 40 degrees centigrade, and sun shines here, it takes a few hours for the heat to come from this side to inside. And when heat comes here or reaches here, it is already during the night, for example. And during the night, sometimes inside we need heating. And therefore, the heat of the sunlight would be used here. In the other opposite side, when it is in the summertime, here maybe it is cool. And when the cool somehow is protected inside. Therefore, if you use build a wall or a roof with high thermal mass, you could save lots of energy. Now we go to the fenestration, to the windows. They are smart windows. It means they automatically open or close, and they adjust themselves with the situation, which is the wind speed and the orientation of sunlight. Therefore, you can have natural ventilation with an automatic system. Here they have used triple glazed windows. Here I see that we have some windows here with some glasses. I'm not sure, are they single glaze? I guess they are single glaze. Most of you single glaze, but in general, if you use double glaze or triple glaze windows, that would be very good insulated against thermal transformation. Therefore, using triple or two or double glazed windows and doors are a good solution for energy saving. Again, this is the situation for the windows that I talked about before. This is the ventilation system. As you can see, it is a very complicated system. It is designed by special engineers, and they try to, even here, as you can see, they have carbon dioxide sensors. It means that check the CO2 in every space. If it is more than maximum which is allowed, somehow the ventilation system starts in order to reduce the amount of CO2. And also there are sensors for thermal load, and they check the temperature in every space, and if something goes wrong or it's not in the comfort limit, they will change it. In order to use the wind energy, as you can see here, there are some intake equipment as here. When winds come here or there or this side, it would be taken inside the building. And you see this is some holes inside here, and they are designed, and they are able to block it from inside. It means that if, for example, if it is in the winter and you have very cold wind, these holes would be closed and wind would not come inside. Therefore, air intake system is one of the fundamental elements in this building. This is the energy that they take from sun. Each building you can see, and it is according to the need of each building. For example, if this building consumes about 400 kilowatt energy, the amount of solar panels is the same. It means that every single building produces its own energy which it needs. It means that during one complete year, the energy consumption and energy generation of each building is nearly zero, which is very important. It means that this building does not need to get energy from other sources. Well, we need always to have energy for other sources, but it gets into a minimum. And as you can see here, by this system, there has been 81% reduction in energy consumption. At the same time, it reduces the energy consumption, and at the same time, it produces energy itself. We call it a zero energy building. Such buildings, without these technologies, were used to be built in many countries. In Indonesia, I have no idea, but I'm sure you have had here. But if you come to my country, to Iran, almost, I would say more than 80% of the buildings were built as a nearly zero energy building. I can give you some slides if we have time later. Here, there's this monitoring room in the building, in each building, and they are monitoring everything. And checking is automatically done by the computers and software. But some people also are checking if something goes wrong, or they would adjust it and resolve the problem. Now you can make a translation, and we go to the case studies.
Okay. Materi yang ketiga yang beliau jelaskan adalah tentang zero energy building, di mana ada 3 karakteristik. Yang pertama adalah untuk reduce atau mengurangi konsumsi energi, arahnya adalah ke zero net energy consumption atau zero net konsumsi energi. Kemudian ada yang kedua adalah total energi dalam 1 tahun sama dengan jika kita menggunakan renewable energy. Dan yang ketiga adalah mengurangi greenhouse gas. Dan mengapa kita perlu menggunakan, mendevelop ZEB atau Zero Energy Building ini? Karena saat ini kita sedang menghadapi krisis energi. Yang kedua adalah fungsinya untuk mengurangi konsumsi energi. Dan yang ketiga melindungi lingkungan untuk generasi berikutnya. Dan bagaimana kita menerapkan ZEB atau Zero Energy Building ini? Yang pertama adalah memilih site area terlebih dahulu dalam pemilihan areanya. Kemudian yang kedua adalah dengan mengurangi penggunaan energi dengan mendevelop passive designs yang tadi sudah dijelaskan. Kemudian yang ketiga adalah dengan menggunakan renewable energy. Untuk passive design sendiri tadi sudah banyak dijelaskan, ada tidak adanya alat bantu seperti atau mengurangi alat bantu seperti ada artificial lighting atau lampu, kemudian air conditioner, heater dan lain sebagainya.
Okay, thank you. Now we go to the last part of lecture today. Let's go to some case studies. In this the Nevian countries, they have been very successful to develop strategies for smart buildings and smart cities. I give you some examples. First, we go to Sweden. In Sweden, there are so many cities. There's a town called Borås. And this is the reference that I have used. The name of the reference is here. If you like, you can go and read the paper. Well, this is the Borås in the south of Sweden, as you see. And these are some views of the city. If you have a look here, it is the waste management system. First, there is waste generation by the people. Then we have waste handling, separation, storage, and then processing. It means that maybe more than 90% of the waste would be recycled. Usually we have from 0 to 20% that we cannot recycle, but in general, more than 80% is recycled. As you can see here, it is the consumption or waste generation. Some part is reused. For example, if there's a plastic bag or paper bag, we can directly use it again. Some are recycled, as here. Some are used for energy. It means energy recovery. And well, about 5 to 20% that we cannot reuse or we cannot recycle would go to the landfill. Therefore, this is a target. If we get up to or around 80% recycling or reuse, that would be a good achievement. Again, here in this city, what they do for a smart building is management of heating, management of cooling, using biogas, using hydropower, also waste management. They would do it as I explained here. They have drinking water production from ordinary rain or ordinary water. Also, they have wastewater cleaning. They have producing of electricity from recycled materials, and also they have services, organization services within waste management and efficient energy use. Therefore, if you have a small city like this, different departments are in charge of different parts, as you see here, and they make a smart and a successful smart city. Here, there's a diagram from, say, 1990 to the year 2008. This is the amount of landfill or the amount of waste which is not recycled or it is not possible to recycle that. As you can see, in 1919, there has been about 100 tons in the landfill, but in 2008, 100 has reduced to less than 10. It means less than 10%. And here today, we are in 2023. Probably this has been reduced. As you can see, during 20 years, they have been able to reduce the amount of waste which is not recyclable nearly by zero in the city, which is a very good achievement. But as you can see, it took them 20 years. It means if today we start, say, in this city, maybe in 10 or 15 years we can do it. Maybe more if the city is large. Let me go to the waste collecting methods. As you can see, even here, this sort of separation is very common at the moment. But in 20 years ago, not so many cities has such a simple separation. Okay, but today everywhere you go, it is, and we can use it. Still in some cities, still we don't have such a system. This is the separation unit at the plant that we have. Such a separation system was not very common, but right now many cities have. But remember, 20 years ago they didn't have that. Let me go. This is the combustion of weights. I'm not going to explain it. And this is the emission. When you consume or combust the waste, you get you send CO2 into the nature. As you can see, there has been a big amount of emission 20 years ago, but you can see it is reduced. It means that greenhouse gas is reduced by more than 90% in that city. Let me go further. As you can see here in the city, they use cars or buses which use electricity, or they use biogas. Biogas is produced by the wastes, as you can see here. Even this computer, as you see, these are very old computers. You don't see such a screen anymore, but 20 years ago, they used this. And these are the person in charge, say in 10 years ago. This is their motto, this is their goal in that city. A city free from fossil fuels, which is very important. It means that we go for zero greenhouse gases. And this is the way they traveled. From 1959, this is their journey, which were down, now they're here. They are near to their dream, which is very good. I hope that every city in the world someday comes to this location. Now we go, would you like, now we go to Stockholm port. It's a very large port, as you see in Europe. And as you see here, the port itself is a smart grid, a smart network as a sustainable city project. They started a few years ago in order to make it sustainable, and now they have reached that goal. As you see, it has been around 2000, and their target for 2020, which already passed, is to have 50% renewable energy, fossil-free fleet of vehicles by 2030, maybe in 7 years from now, and also target for wind tower by 2020 to produce 20% of Swedish power production. It means that right now more than 20% of their energy is produced by wind. This is the port, as you can see. And as you can see here, what they did for local sustainability program included local public areas, energy system, local recycling, water and wastewater management, transportation, homes and services, lifestyles and businesses. What we talked about in last slides. Therefore, they concentrated on these items and tried to elevate its efficiency, and at the moment today they got what they wanted. I just therefore the main objective are these elements that we see. If you work on all of this, maybe in 10 or 20 years, you can get a good and smart city. Now we go to Finland. As you can see here, and here there's a city. It is called Turku. Okay. The city was rebuilt according to a grid pattern of rectangular blocks in which the relatively broad streets should prevent raging fires. Okay. In order to have a sustainable energy plan or program or such a thing, the strategy focused on three main objects. First, the type of energy usage. They elevated the usage of energy, energy supply, and also transportation and logistics, and their use was somehow focused on in order to make efficient, energy efficient street. As you can see here, they had a program for traffic management. Okay, and here they were encouraged to use bicycles or to use some applications in order to find the nearest and best parking for the drivers. Also, the vehicles, the cars were designed in order to have zero emission technology. In order to, for example, they were encouraged to use battery or electric cars. Also, they produce biogas by waste materials instead of using natural gas in order to reduce the emission. And also, they focus on building smart buildings. As you can see here, they try to go for buildings which could be controllable and could be managed by some energy efficient devices and so on. Now we go to the city. As you say, these vehicles are mostly electric. They are using electricity, and electricity is produced by biogas mostly, or by sunshine, or by wind. Here you have a smart grid in the city. As you say, every single building is a smart building, and the operational function is somehow controlled by the municipality in order to optimize their usage and energy consumption. Also, they try to use the heat stored in the soil for heating the building and so on. As you can see, maybe here. Okay, it means that let's come in here. No, I don't have such a. But anyway, here, as you can see, you have smart lighting. In many countries, you have it. When it is sunshine, the lights are off, but then automatically they would increase. Also, as you can see here, there are some smart parking, which means that when there is not enough space for the cars in order just to find the car, they can automatically, the empty place in a parking is connected or is announced to the driver, and he can use the empty parking. As you can see here, there have been some successful practices in Europe and in out of Europe, and I think everybody in the world can reach such a goal if we have a good management to do that.
Okay, thank you, Professor Merdad Hijazi, for your presentation. So we've been discussed about the smart cities, which the characteristic, the material, the smart building, and zero energy building. And the last things that he shares with us is the case study of Scandinavian and Stockholm port and Finland, which give us a new perspective that the smart city is possible to achieve, even though it took a long way to, the Boras city, you showed that they started in 1959, but it happened, they achieved the smart city thing. So it's possible for us to do the smart city by a single step from now, maybe. Okay, so can we start the question answer session, right? Okay, so that's the presentation from Professor Hezazi. If there is any question from our participants by in the room or through online, for everyone who join us online, you can put your question in the chat room. And for everyone who join us in the room, you can just raise your hand and ask your direct questions. Pak Yusuf mau bertanya, Bapak, monggo. Oh ya.
Thank you for the chance. 2 questions only. Mr. Rejasi, we have a problem with developing countries like Indonesia, Iran, increasing the number of people, then followed by increasing standard of life for human being, and then feeling comfort getting higher. In the past time, we just only use cross ventilation, but now air conditioning. That's how come and how to overcome this problem. The second one is, it's your opinion or your conclusion that using process in level of community better than individual level. I mean, if you use electricity by community level, can eliminate the consumption of maybe electrical or power. Is it your conclusion like that? Okay, thank you.
I have a problem with this. Okay. Thank you for your question. It's a big question. When we have a country with a high population, and sometimes a country with cheap energy, like in my country, when you pay for electricity or gas, I would say near to free. In this case, how can we guide people to go through this? It is very difficult. I think public public awareness, I would say, is very important. If the people are aware of that, even if the energy is cheap, even the facilities are not enough to manage them, they start saving energy or first is, I think, public awareness. I remember in my country, you know, when you are driving, usually you should use your car belt. But a few years ago, it was not compulsory in many countries. The first time in my country, the cars were obliged to have car belt seats, and the drivers were obliged to that. For first few months, people were very reluctant to do that. There were two ways. First, to give penalty to the people. The second was to aware the people. If you don't use your seat belt, and if you make an accident, you will die. That's simple. And after that, people say, yeah, that's it. They should use it. It is important. Therefore, I think most of the examples that we saw, they are very small cities with a low number of people. And some of the cities are people with high educated people, because in these cities, it is easier to do that. But when you come to a city like in Isfahan, more than 2 million people, maybe here in Sebuah, maybe 1-2 million, I don't know. That would be very difficult to do. But I think we should start from somewhere. And the first step would be the awareness, I would say. And I think after a few years, people would understand that it's better to do that. And they should, it's for your, not for you yourself, it's for your children, for next generation. And I think bit by bit, we will be successful to do that.
The second question, could you please repeat? The second question. Oh, for electricity. Okay. Okay.
Okay, to reduce the energy consumption, well, we know that more than 30% of energy consumption belongs to the buildings that we live in. That would be a house or something like that. About 30% belongs to the plants. You have big plants to make electricity, so on. I think the first step would be for the buildings. You know, in most of Western countries, there are strict regulations in order to have double glazed windows and so on. In my country, the regulations for energy became effective just 10 years ago. It means that most of the buildings which are built before 10 years ago, they do not meet the requirement for energy standard. Okay? But since then, the buildings which are built in my country, they have the standard for energy. And there has been a calculation that if a building is constructed according to energy standards, the cost would increase just about 5%, not more. But the energy that can be saved is more than sometimes 30 or 40%. Okay? Therefore, I think the building code in each country should enforce energy requirement. I don't know whether in Indonesia you have such a standard or not. And then I think there is a need for changing the equipment for cooling and for heating. Yes. In the building that I live myself, it's a complex. The building has been built about 18 years ago. And the system we have for chilling and for heating is now 18 years old. There is another complex near to us, which was built last year. The system they are using for heating and chilling is more than 50% more efficient. Why? Because the money we pay for the electricity is more than double what they pay. It means that increasing the quality of the systems, the lights also, that would be very important. And the other thing is, in Iran, most of governmental buildings, which are very old, they consume many energy. And the government has asked or has urged its own buildings to be renovated, and it subsidized for that. It says, if you reduce your energy consumption by 50%, we will give you another 50% reduction for what you pay. There are some sort of punishing requirement and also the opposite. I think bit by bit, we should do that, but it needs a program, maybe for 10 or 20 years, especially for the countries which are not used to such things. I would question, do we have an energy code or standard for building? Yes. Yeah. It is, yes, yeah, exactly. But when it's small, it is not. But here in Iran, we have organization. When the building starts from the plans and design, it is checked. And when it is finished, again, it is checked. If everything is okay, no problem. They give certificate for the building. You can use it, you can sell it. Otherwise, they stop it until all the problems is resolved. But it is a new procedure, maybe 5 years or 10 years. What should we do with other buildings which are already built, and more than 90% of the buildings are those buildings which consumes the energy. I think it needs time. As you can see in Europe, in a small city, it took them 20 years. For us, maybe more than 20 years. Yeah, thank you.
Okay, thank you for your answer. Maybe we can admit another question from, maybe one question from the participant because we have limited time. Okay, thank much. Dengan Mas siapa dan sebutkan pertanyaannya. Bisa berdiri Mas biar kelihatan.
Okay, thank you. Good morning, Professor. Thank you for the insightful presentation. My name is Ervan Sarizal Variamen from Civil Engineering ITS. First, allow me to ask 2 questions. The first, in my view, integrated technology into urban city will change traditional system to smart system. And it means will change to the traditional habits into the smart habits, maybe including smart infrastructure, smart living, and then smart environment. And in my view, this situation, it's difficult to be adapted, especially for low education background or maybe low income level, and then older people. And the question is how to mitigate these social risks. And then the second question, how to enhance the social sustainability in smart city. Okay, I think that's all, sir. Thank you.
Thank you.
Thank you for your question. First question is a very important question, especially maybe in your country and in my country. We have so many old buildings. Now it is abandoned in a good condition, and now it could be reused as a hotel or as a restaurant, or even you can live it, okay? In my country, what they do is the government give a subsidies of 50%. It means that if the owner wants to evaluate the function to use the smart facilities inside the house, 50% of the cost would be paid by the government, okay? Because you ask about low income people, that's true. Therefore, in my country, if the building is a historical building or it has a historical value, which is good to preserve it, the government would subsidize 50%, and also the government would provide experts to change the facilities in the building. Okay. Second question about the people, ordinary people, how to change their attitude. As I said, they need education. Education needs starts from the school. Some courses should be added in the school classes, and then that would be for next generation. For example, your children. And it takes about 20 to 30 years. Those children who will be sit here, they know how to do that. But for the present situation, I think the youth generation, the young generation who can understand it, you should, now you're construction management engineers, okay? You should ask your clients who want to construct people and educate them that it is important, and you should do that. Also, government has the responsibility to train people. It could be through television or in school and so on. The government should subsidize. The government should make some punishment for some people. And I think by global management by the government and also local authorities in every city, it is possible to change the attitude in 10 or 20 years. I think it is possible. Thank you.
Thank you, Professor.
Okay, thank you for the question. Since we have limited time, let me jump into the conclusion. So we are trying to realize, or we are trying to create the smart city is a long way to go. So it will keep us to protect our future generation, protect our environment to our future generation. So as engineer, now we are all here as an engineer, and so we can start by create the passive design that Professor Hijazi have explained to us. Is there any closing statement that you want to add?
Yeah. Because today is the last day I meet you, it was my pleasure during these 3 days to be with you. Very intelligent students. Most of you understand English and you can speak English. It's a very good priority. I thank you very much again for your hospitality and your Professor Dr. Yusuf and also you. I thank you very much. You can be in contact with me. You have my email address. Inshallah, we are going to make an agreement between two universities, your university and my university in Iran. And whenever you decide to have a visit from Iran as a student or as a non-student, you can just apply to my university through your professors, and we try to host you in Iran as much as we can. It was my pleasure to be here for 2 years, and I hope to see you again in future, maybe in Iran or again maybe here. Thank you very much.
Thank you. Give it applause for Professor Merdat Hijazi. I would like to say thank you too. I have led this discussion for these past 3 days, so thank you for your cooperation. And after that, we will have a small ceremony, closing ceremony. So please, all of the students will stay in the room for the closing ceremony. Okay, thank you. I will close this discussion, our last day of our guest lecture series. Thank you very much for your our participants. Thank you for your presence here, and see you at the next year of guest lecture series. Okay, hopefully. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Speech from our Okay, thank you to Professor Hijazi for being willing to fill out this guest lecture session, and also Ibu Ragil for bringing us to very productive session. There will be a speech from Bapak Hoiri. Kepada Bapak Hoiri, dipersilakan.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. I would like to say very thank you to Professor Hijazi that's already shared to us about his wonderful experience regarding to retrofit, and also this today's session about the smart city and this feature. The first and second topic is very related to our curriculum in our study program for strengthening structure and also retrofit for rehabilitation or restoration of building. That has very strong relationship between your material and your presentation with our curriculum. And your experience is based on the worldwide experience. So that's enlighten us and give us broaden our perspective in terms of how to strengthen and retrofit the building. And the last material is talking about smart city. I think that's our future. So you give us the perspective in the future regarding to the civil engineering and building and so on. And regarding our, and also give us the internalization approach to our department and our student also. And you apologize if maybe in the communication that some of our students can speak English very well, but your material is delivered to us is very good. Thank you very much for your coming and your speech in the last 3 days. Thank you very much. Kita berikan applause untuk materi sesi.
Okay, now there will be a gift and certificate submission that will be given by Bapak Hoiri. Okay, everyone, we have reached the end of the event. On behalf of Kamit Odati, we would like to say thank you for your active participation and have a great rest of your day. See you on the next event. Wassalamualaikum warahmatullahi wabarakatuh. Kepada para peserta mungkin bisa diharapkan untuk stay di ruangan untuk dokumentasi.
Teman-teman mahasiswa bisa berdiri juga biar kelihatan semua. Mohon untuk peserta yang belum scan barcode, silakan scan barcode karena untuk kebutuhan sertifikatnya nanti. Jadi jangan lupa untuk scan barcode-nya.